Okay, so I'm trying to give you step-by-step instructions for how to graph these. The first thing you're going to want to do is make sure that your formula is, or that your equation is in standard form. So make sure it looks like y equals ax squared plus bx plus c. Get all your x terms on one side and your y on the other side and all that jazz. You're going to want to identify the values of a, b, and c because we're going to be using those numbers as we work through the remaining steps. So off to the side, you'll just write A equals, B equals, and C equals based on your equation. The next thing you're going to do is find the axis of symmetry using this formula right here. And I would highlight that if I were you because it's going to be important that you have that formula written down as we go through the practice. Okay, and then basically we're just going to be constructing a table of these values. Some of the values I'm going to tell you what to use, and others you just get to pick points based on what makes sense for the problem. Once you've got at least 5 points in your table, then you're going to plot those points and connect them with a U-shaped curve and arrows. One additional note that I need you to realize is that if your A value, so that's, remember that number right there in front of x squared, if it is positive, then this quadratic function will open upwards. So what that means is if A is positive, then you're going to have a parabola that looks like this. If A is negative, that's when it's going to open downward. So that's when it's going to look more like our little angry bird here. If A is negative, let's see, negative, then you're going to have something that opens downwards like this. Okay, so our example 1 is y equals x squared. I'm going to try and walk you through and show you how we put this on the graph using a table, because that at this point that's going to be the easiest way to go through these examples. So I gave you a couple of tips. The first thing is we've got to make sure it's in standard form. It is this time. We didn't happen to have a bx or a c. That's because both of those values are 0. So all we have is y equals x squared. Identifying the values of a, b, and c then is fairly straightforward. I have an understood 1 right there. So that means my a value is 1. Because there is no b, I can assume that that b value is 0, because 0 times x would mean nothing was there. And same thing with c. I'm going to have a 0 there. Now, because this a value is positive, that means this parabola is going to open up. And as we start plotting points, you'll see that it naturally takes that shape. The next step is that we are going to find the axis of symmetry using this formula x equals negative b over 2a. Well, we've already identified those values, so we're going to plug them in. Negative b would be negative 0 over 2 times 1, because a is 1. That equals 0 over 2, which is 0. So my axis of symmetry is the line x equals 0. As you find that axis, go ahead and plot it on your coordinate plane. Remember that lines that have x equals a number are going to be vertical lines. And for the most part, well, for all of this course, we're going to be looking at vertical axes of symmetry. So x equals 0 ends up being this line right here. So that's going to be my axis of symmetry, which means anything I do over here, there's going to be a mirror image over here on the negative side. All right, the next thing I want to do is start constructing a table of values for x and y, and it says I need at least a total of 5 points. Choosing what values to try and find, though, can be a bit tricky, so I've given you a couple of tips here. The first thing I want you to do is put whatever value you found for your axis of symmetry, put that in the center of your table. So we found that the axis of symmetry was at x equals 0, so I'm going to put 0 as my middle x value. When I plug this value into my equation, so remember my equation is y equals x squared, because that was my example. When I plug 0 in there, 0 squared is 0, so that means my output there is 0. That gives me my vertex. Okay, so now I can fill in this next point here. My vertex is 0, 0. So I've got a point right there at 0, 0. Because we know this is going to be opening up, this is going to be a minimum of 0, 0. There won't be a maximum. And I'll show you why when we start graphing this. You'll see why we end up with a minimum here and not a maximum. Okay, the next thing I give as a tip is to always use 0 as one of your points, and I tell you that this gives you your y-intercept. Well, in this case, since my axis of symmetry ended up being 0, that point's kind of already been taken from me. I've already used 0, 0. So we can go ahead and write that down as our y-intercept, because if I'm going through that origin there, that's where I cross the y-axis. That's also where I cross the x-axis, so at least one of my roots is going to be 0, 0, so I can go ahead and fill that in as well. Okay, so let's go ahead and start picking some values. Usually we like to pick a mixture of positive and negatives, and since 0 is right here in the middle, we can go ahead and pick a -1 as one of my values. So I'm going to plug that into my equation. In place of x, I'm putting -1. And -1 times -1 is 1. So that means that when my x value is -1, my y value is 1. I'm going to plot these points as I go, because -1, 1 is right here. And my last point says, remember that your axis of symmetry serves as a reflection line. So every point we calculate is going to have a mirror image on the other side. And what that means is, if I've got a point at -1, 1, that is one space away from this axis of symmetry. So I'm going to have a point right here that is one space away from that axis of symmetry on the right, which gives me another point to put in my table. I'm at 1, 1. And if you want to check to make sure that works, you can plug that into our equation, and 1 squared is indeed 1. So that works. We've got 1, 1. Okay, let's try it again. Let's go ahead and do -2 here. I'm going to go ahead and put this up here. So remember, I've got y equals x squared. I'm going to put -2 in place of x. -2 squared means -2 times -2, so that's 4. Okay, so let's plot that point. We go over 2 and up 4. And remembering that this is a reflection line, this is 2 points to the left, so I'm going to have a point that's 2 points to the right of that axis of symmetry, which means when x is 2, y is 4. So there's my last point. And once you kind of get the hang of using that reflection line, you don't have to recalculate everything, but just to show you, let's say y equals 2 squared. 2 times 2 is 4. So that verifies that last point. Now, step 5 is to plot the points. We've kind of done that as we went along, and connect them with a U-shaped curve and arrows. So what that means is I'm going to have a parabola. Just fair warning, I am horrible at drawing parabolas. I'm going to retry that. Absolutely horrible, especially with the computer. Oh my goodness. It should go through the lines, guys. Oh my goodness. Okay, that's good enough. It should go through the points, but you know what I mean. Okay, now notice this is opening upwards, so our prediction here based on A being positive is correct. Also, because it's opening upwards, I have a bottom point, which is why we said there was a minimum, not a maximum, because there's never going to be a top to this parabola. It's going to keep going forever. And that brings us to talking about our domain. When I look at this, choosing x values is completely unrestricted. I chose to pick points that were kind of close together so that I could get nice pretty points here and not have to extend my coordinate plane really far. But I could have plugged any x value I wanted, any negative value, because this thing is going to keep getting wider and wider as it goes up, which means my domain is all real numbers. My range, however, is a bit different. Remember, to check your range, you're going to start at the bottom. I'm going to draw myself a little line here to show you. Oops, that's really fat, but it's okay. You're going to start at the bottom, and the first value I see in the y-axis is a 0. So that means the beginning of this range is 0, and it's going to continue going forever and ever and ever, because I'm never going to hit a top to this range. Those arrows mean that this is going to keep getting taller and taller forever. Okay, so the end then of my range is positive infinity. Right? It does equal 0. It never actually gets to positive infinity, so that's how we would write that. If you were going to use our inequality symbols, then we would say 0 is less than or equal to y, and it's less than infinity. Okay, so either way of writing that is... Okay, so this particular parabola is what we call the parent function, meaning that is the most basic parabola. So it's important for us to show you this one because it hasn't been shifted or stretched or anything. It is just the basic parabola.